So I find that when you are doing exponential graphing, that usually you want to get three main points. You want to get a -1 value for x, 0, and 1. So let's do that here. That just means we're actually going to plug into the formula y equals 3 times 2 to the x is going to be -1 minus 1 in this case, power. And so that can all go in most calculators. They can handle that just fine. Let me pull one up so you can see just as an example. So you would do 3 times 2, and then you would look for a button like this that puts the exponent or the cursor up in the little exponent there, and then -1 minus 1. So -1 take away 1 is what we've got there. All right. And that tells us that this first point is up 3/4. Now, a lot of calculators, I think, are going to automatically give it to you as a decimal. So 0.75 there. If you're not sure, you can always, if you get it as a fraction and your calculator won't change that, you can always divide fractions. That's just a division bar. So 3 divided by 4, it's 0.75. Okay. So I know at -1, I'm up 0.75. So think about where that is on the graph. This is a coordinate point, an XY coordinate point. So we go left 1 and we go up, not even all the way to 1, 0.75. So you're approximating. This is a sketch of a graph. All right, let's do the 0. So y equals 3 times 2. Now x is 0 to the 0 minus 1 power. And so I'm going to grab my calculator, and I've got 3 times 2 exponent 0 minus 1 power, or the -1 power. And you get 3 divided by 2, which is 1.5. So that means at 0, I'm up all the way at 1.5. 1.5 is between 1 and 2. So again, approximating where that point is. All right, let's do 1. Y equals 3 times 2. Now x becomes 1 to the 1 minus 1 power. Now you can type this in your calculator just like we did the previous two, but also think about 1 take away 1, that's 0. 2 to the 0, anything to the 0 power is 1. 3 times 1 is 3. So this is at 1, 3. That one's nice and clean. All right, and now comes the fun of sort of approximating where the graph's going. And if you need to be more specific, then keep going, do 2, 3, and so on. It's going to very quickly go off of your graph, though, just know that. But this is an approximate sketch of the graph for this equation. Two things. One is that this is a growth, and we can see the exponential growth happening here. And then also this is moving the graph right 1 when you are in an exponent with the x, whatever's happening there, it does sort of the opposite of what you'd expect. So our x minus 1 means it's going to actually go the opposite direction. It's going to go right 1. And so that's why we have like this sort of key point here. It's over 1. The parent function or the original function would have been more like here. And so it would have sort of been a mirror of it, but it would have been over here. And so the blue one, we can see it has moved to the right. All right. I hope that helps as you're sketching exponentials, and I will see you next time.